Afternoon, Susan Brown in Funtime Toys. My name is Demetrius Armanis and I'm currently employed at Griffith Engineering, working with Team E8, and we've shown great interest in the Mousetrap car. We have produced a prototype and a finished model of the toy car and wish to discuss our conclusions. Our entitled model was worked strictly under the conditions made by yourself and the company. The car was built to drive along a 5 metre track at the fastest possible time, with the only force used to move the car is a mousetrap. The mousetrap spring could not be modified in any way, although a lever arm was permitted. The toy car must be safe for children 8 years and over to use. And lastly, the production cost must remain under $50. The basis and origin of the project was based around certain mathematical concepts. Torque is one of the main concepts, and torque is the force acting on an object, causing the object to rotate. Torque is our sole force used to power our toy car, and torque was produced by the mousetrap. Friction was also a major factor in the project. If there was little friction between the wheels and the track, the wheels would spin out during the takeoff stage of the trials. This caused the car to barely move anywhere, even with a full snap of the mousetrap. Inertia was another key factor in the construction of the car. Due to inertia, if the car was too light, its high velocity would drop quickly over time, whereas if the mass was too high, the mousetrap would not have the power to move the car to a high velocity. We considered all factors contributing to the efficiency of the toy car and came up with 3 parts of the car that we thought were the greatest difference to the speed of the car. The mass of the car was the most important part of the efficiency of the car. We tried to make the car as light as possible by removing large portions of the wooden chassis. The weight removed made the car substantially faster than the original version, improving the time by over 2 seconds for over the 5 metres. We also decided to use smaller wheels than the provided ones in order to get a faster car. Each rotation of the axle is much faster with the smaller wheels compared to the original wheels, which were CD discs. 2 designs were made to test the difference in the mousetrap with and without the lever arm, although it was already known that the addition of the lever arm would make the car much quicker than without it. After considering all factors contributing to the efficiency of the car, the group discussed the design process. The design process decided upon by the group was simple but effective. The first step in designing the car was to consider all variables contributing to the velocity of the car. These variables included mass of the car, the torque of the mousetrap. It was then decided to draw our desired car in SolidWorks to get an idea of the car in a graphical representation rather than in our thoughts. This way the group was not confused on what we wanted to build. Next was the construction stage of the project, which is where we built our desired design. And then after the design was constructed, modifications that were necessary were conducted. We decided we needed to add more torque to the mousetrap, as we wanted a faster car. The addition of the lever arm made a major difference and tripled the amount of torque compared to no lever arm. The spin effect by the wheels was counteracted by rubber bands attached around each of the wheels for more friction. This way, spin wasn't occurring within the wheels, and all energy was used in driving the car. The results show that the prototype with the lever arm made a faster car with a time of 2.94 seconds over the 5 metre track and an average velocity of 1.7 metres per second. The group was happy with the result and all requirements made by yourself and the company were fulfilled. The car completed the track in a reasonably quick time and no modifications were made to the spring of the mousetrap. The group only spent $10 out of the $50 budget, and it is safe for the use of children under the ages of 8. Thank you for listening to our proposal of the design of your new toy car, and we hope you choose our model.